IAB. My name is Nicholas Kwan, and this is a presentation just on my internship at Tesla Motors and some of the things I worked on, namely with quality engineering, application, and implementation. My academic advisor is Liz Schlemmer. So the problem statement. There were too many quality defects that appeared at inspection, end of line repair, as well as the Tesla Service Center. Namely, these three defects. So the windshield wiper misalignment, that was the most recent thing I worked on. Pretty, not a huge thing that affects the functionality of the car, but this was one of the most common reasons why customers actually brought their cars in to the Tesla service centers and complained about them. And so this was the windshield wipers actually not hitting the windshield correctly. The other smaller things that I worked on, actually when I was at the internship, the Elon would always complain about the rear seats and how there was too big of a gap, and it would vary from car to car. Also not a huge thing, but the main thing that actually did affect functionality of the car that one of the defects that I reduced was the charge port door was malfunctioning. So didn't function well. So it actually didn't open for a lot of the cars. So customers would come in and not be able to charge their cars, which is a pretty big deal. And the second area of my internship when I was there, and there was no effective way in deciding which defects were, well, quote unquote, most important. So the last two defects were the things that I worked on back in 2000 and late 2011, and before Tesla was even a profitable company. Their stock price was about less than $30, about 250 now. So, and we were not profitable yet, trying to become profitable, and we were working on things like the rear seat gap. So when I was working on that, I was thinking to myself, there's some of the most talented engineers in the world working here. Why are we not working on things that are more important, especially to get to profitability? Anyway, so the literature review, a lot of it was quality engineering resources, and also with quality engineering defect reduction, as well as quality function deployment. I realized that a lot of the issues that customers were complaining about, they actually weren't properly established in terms of their expectations. So with the windshield wiper, there were some issues that could have come into play with quality function deployment, and reducing those complaints would be a way to solve that. And also industrial engineering literature. And there's some of my works cited. Goes on to the next page, and there were a total of 16. I think 11 of them were print, and then 5 websites. So the expected deliverables were the temporary and long-term countermeasures to reduce the defects. So we wanted to literally eliminate or eliminate them on the line. And when I mean eliminate, I mean reduce as much as possible, or reduce all the non-normal causes. And so we wanted to find a temporary way to pretty much put a band-aid on it, and while the band-aid was applied, pretty much find the long-term reason why they were occurring. Normally using the 4M methodology that was pretty popular there with a lot of the engineers, which is it the man, is it the material, is it the machine, or is it the method causing the defect? And the other expected deliverable was a new way of reordering the quality defects to increase value driven to the customer and the company. So pretty much finding a better way to work on these defects and just prioritizing them. Because like I said, there was some defects that customers weren't even talking, quote unquote defects on our standards, that customers never even complained about, and that we were spending a lot of time and the end of line repairing. So that was it's a huge cost for Tesla, that repair time that prevents cars from getting sent out. And so the solution for in general, so we used FMEA, 5 Whys, and a lot of the engineering tools to reduce the defects, and as well as to create that priority management solution using database management tools. And going a little more in depth, I'm going to talk about my favorite defect that I worked on, which was the charge port door. So in the top left of the screen, that's where the charge port door is. That's a picture I took when I was doing a capability study, just trying to quantify, put some numbers behind what was actually going on. So the door, it usually, there's the red portion, the little reflector, that's the charge port door, so it usually swings out, and it was catching the edge of the actual aluminum body. So that was the defect. And then the engineers, or I mean the services, end of line repair, what they would have to do, because certain cars they wouldn't open, they would have to remove the entire lamp, add on some washers, and then put it back on, and that was pretty much what they'd do. And the bottom was just one of the washers and foam washers that we had to put on. And so the actual solution, so the band-aid that I mentioned was, something that was really cool with Tesla was, they move really, really fast. So I spoke to a lot of the end of service or end of line repair technicians and found this was what they were doing. So it was hard to predict which cars would have the defects. So pretty much we added this operation, this small little task, adding those rubber washers onto the actual the light for every single car. And this would reduce the time. It would a lot more standardization, as well as it would reduce a lot of the time to take off the light, put the light back on, test it again and again. And so that was the short-term solution. Long-term solution, went through the 4Ms, checked a lot of specifications for the light to see if it was the quality, the supplier. I realized that a lot of the defects, they were even from operator to operator, as well as different shifts. So it wasn't the man necessarily. And I watched a lot of the process. It was being applied, the charge port door and the lamp. It was being attached the exact way that that we wanted it to, that it was supposed to be. So ended up being, looking more and more, ended up being the welding can. It was actually a few millimeters off of the aluminum body. So looking at a lot of the initial reports, as well as what was comparing that to the actual data of the cars, doing a lot of capability studies, found that that was the issue. So we ran a quick study and tested it on, I think we did just 8 cars, saw a great improvement, and the defects dropped dramatically. And so the third part of the solution was, the top slide is the taking in the service database. So that was pretty much the defects that came into service. And then the bottom was kind of my proposed solution, pulling in the service complaints into how we would pretty much decide which defects to work on. And so the defects that we would work on currently, they were just based on the amount of defects that we saw in the factory on inspection. We didn't really take into account which defects were being worked on at the end of line repair or service. So all this time that technicians were spending to change all these gaps or all these defects, all that time really wasn't taken into consideration, and a lot of the parts we'd have to replace. So a lot of 312 stuff, a lot of CSC 232 Excel work to make a good way to present this. And then going into our orientation, the things that I used. So use 223 to analyze processes, 312 for databases, 314 cost benefit analysis, 430 for quality, and the economic analysis. So the defects for vehicle, the top left is from the charge port door. So 1 out of every 10 cars ended up having this in the factory that we had to fix. The average time actually was a long time, a little over an hour to complete the entire repair. And so the way Tesla likes to analyze their savings is using the repair wage, $3.85 per vehicle. You can pretty much see the savings in Q2, which we calculated, and the savings per week. And then the right was the windshield washer. I don't have enough time to talk too much into it, but you can see the numbers there. And then the bottom image was just a quote from Elon, which was cool, from a week ago, just saying, in the middle of the quote, this was in his earnings report, just saying how he goes about the issues and looks actually what the customer is reporting. And 2 years ago, before I proposed the idea to involve service, Tesla was not even doing this at all, putting all the using the customer data to influence their decisions in the factory. So it's really cool that that's being still applied to this day. And so yeah, that's the presentation. Thank you very much, and hope to meet you guys all soon.